Welcome back to Dave Does Math from Home. This is now part 3 of our series on volumes of rotation using the pipe method. I was right in the middle of an example of doing this problem using the pipe method, a rotation around the x-axis using the pipe method, which means that we have to switch everything into terms of y. It's right in the middle of it when my camera died. Sorry the last video ended so abruptly. But if we're doing a third video, we can pick right up where we left off and also take our time. I was trying to cram all this into 2 videos was probably a mistake anyway. So yeah, third video is good. So quick recap. We are doing this, we have horizontal slices here. We are spinning them around the x-axis to make little pipes this way. Pipes around the x-axis. Each pipe we could effectively unroll into a rectangle. The height is this dimension, which is not an x value. This distance here is the x value. The distance I'm interested in is 2 minus that x value to get this actual horizontal slice of area. So that's the 2 minus x here. We converted this into something to do with y's so that we could integrate. We got 2 minus the square root of y. The length is always the circumference of this pipe beefing, so that was going to be 2 pi times the radius. The radius in this case is a y value, so we have 2 pi y here. And the width, the thickness of our pipe or the thickness of our piece of paper is always going to be a dx or a dy. In this case we've got dy because it's a horizontal slice, and the thickness is a tiny little strip of the y-axis. So we put it all together, and the volume of a pipe is 2 pi y times 2 minus root y times dy. And I was simplifying this. I distributed, the 2y can stay on the outside because it's a coefficient. The y I want to distribute into here. So that's where the 2y came from. Y to the 1 times y to the 1/2 should give you y to the 3/2. And that brings us right up to the part where I was about to write dy. So already we can kind of see that this is a much more difficult integral than when we did this problem. I don't remember if it was this exact problem, but we did this or something very similar to it when we talked about the disk method. And we found that if you're doing this one with the disk method, it's really easy. So part of this example is just to illustrate that you can do it with other methods, but almost every time you do one of these problems, one technique is going to be really easy, and one technique is going to be really challenging. And it's usually doable both ways. The last example we did is only doable one way because of weird integration rules, but usually it's doable both ways. One way gets you nice, easy numbers, and the other way gets you 2y minus y to the 3/2. So choose wisely. That it's doable both ways is the good news. The bad news is I'm not going to tell you which way to do it. So like when I give you a quiz on this material, I'm not going to ask you to do it one way or another. I'm just going to ask you for the volume of rotation, and it's on you to figure out what's easy and what's hard and get your answers. So if you start doing it one way and it seems like an absolute horrifying mess, try shifting your slices around. See what happens if you rotate your slices and slice it the other direction. See if that makes it easier. That's why it's good to be practiced in both techniques, so you can always tell which is going to be the easier technique to use. So, with all that said, I'm going to finish this out. We just need to integrate. We'll get 2 pi times y squared minus 2/5 of y to the 5/2. Oh, we need to talk about bounds as well. This has no bounds. I need bounds on it, and I need bounds for the y values. So knowing that this is x equals 2 doesn't help me. This bottom is probably y equals 0, so that's a good place to start. At the top of this y value is going to be whatever y value I get when x equals 2 gets squared. So that should be y equals 4. So this is my antiderivative. I'm evaluating from 0 to 4, and I'll do that over here. Actually, I'll do it up here. 2 pi times 4 squared minus 2/5 of 4 to the 5/2. When you plug in 0, you just get 0. So that's easy. So you have 2 pi times 16 minus 4 to the 5/2 is 32. So 2/5 of 32 is 64/5. So it's 2 pi times, how many fifths is 16? Is that 80? 80/5 minus 64/5 is 16/5 times 2 pi, so 32 pi over 5 is my final answer here. So, like I said, kind of a weird mess. Maybe you don't know what 4 to the 5/2 is off the top of your head. Not a lot of people do. Choose the technique that works best for you and the technique that makes the most sense. I think that's about it for the examples that I wanted to do. So I'm going to cut this video here. We'll end on a nice short one, under 7 minutes. And good luck with this homework. Let me know if you have questions.